top of page 574, you have some space. You're going to write these 2 steps for the general solution. So whenever they say solve the general solution, or they say the domain is theta belongs to all real numbers, step 1, you're going to solve it like normal. How do you find all the answers from 0 to 2 pi? Just like we did in the 4 warm-up questions this morning. And then, once you've got those answers from 0 to 2 pi, you just have to add 2k pi, where k is an integer, to each of your answers, and that will write every single coterminal angle with them. So after putting an x through example number 1, these are the examples we're going to do instead. Solve for theta, where theta belongs to all real numbers. And we have 7 sine theta plus 1 equals 0. This would be a calculator question, because when you get sine by itself, that is something that is not on your unit circle. So you need your calculator, find your reference angle, find out what quadrants it's going to be in, because step 1 of the general solution is solving from 0 to 2 pi like normal. There's our reference angle. And then quadrant 3 and quadrant 4, there's our 2 answers between 0 and 2 pi. So then for the general solution, now what we have to do is we have to write all the coterminal angles with those ones. And so we just add 2k pi to each one of those where we say k is an integer. And unlike tangent, which we saw before, there is no more elegant way to write this. You have to write these both separately. Another calculator one, because when you get cos by itself, I just have the answer here. So I'll let you see if you can get the answer. I'll put the answer up and show the work after. All right, let's see if you got the answer. Here are the answers. So what you would have needed to do is first get cos by itself, or you'd get negative 1/5. You would find your reference angle by doing cos inverse of positive 1/5. And that answer is equal to 1.37. Then using that reference angle, cos is negative in quadrant 2 and quadrant 3. So you get 1.77 and 4.51. So questions for practice, 5, 6, and 9.